Assalamualaikum warahmatullahi wabarakatuh. My name is Sharifana Anishira binti Saragi. My metric number is AA221840. So I'm going to talk about the humidifications. So what is the humidification? Humidification is the process of increasing atmospheric humidity to ensure comfort, health, and industrial activities. It reduces dry skin, respiratory irritations, and static electricity. Humidifier, vaporizer, and steam generators help to achieve this. It's critical in dry areas and colder seasons, and sectors like pharmaceuticals, textiles, and electronics rely on precise humidity regulation to assure product quality and industrial efficiency.
Hi, my name is Patricia Namitumbar. So for the psychrometric chart, it is a graphical representation of the thermodynamic properties of moist air. It displays various parameters like dry bulb temperature, wet bulb temperature, dew point temperature, relative humidity, and specific volume, among others. How to read the humidity chart? There are 3 steps. For step 1 is identifying the axis. First, find the dry bulb temperature by denotes the various temperature reading in Fahrenheit or Celsius. Second, find the humidity ratio label on the right vertical axis by marking the amount of moisture per pound or kilogram. Third, locate the uppermost curve line on the chart to find the saturation curve. This curve connects the x and y axis and marks the relationship between temperature and absolute humidity when the relative humidity is 100%. And the last one is follow the interior curve line to see various level of relative humidity. On the chart, you will notice various lines that follow the curve of the saturation curve. This marks the relationship between temperature and pressure when the humidity is less than 100%. How to read the humidity chart? There are 3 steps. For step 1 is identifying the axis. First, find the dry bulb temperature by denotes the various temperature reading in Fahrenheit or Celsius. Second, find the humidity ratio label on the right vertical axis by marking the amount of moisture per pound or kilogram. Third, locate the uppermost curve line on the chart to find the saturation curve. This curve connects the x and Step 2. Reading interior marking. First, find the vertical dew point line just to the right of the y-axis. Find the line with dew point measurement in degrees Fahrenheit or Celsius. Second, find the vertical dew point line just to the right of the y-axis. Find the line with the dew point measurement in degrees Fahrenheit or Celsius. Third, identify the diagonal specific volume lines throughout the chart. The specific volume of the air tells you the amount of the air that this chart was meant to measure, normally within a range of 2 to 3 m³ per kg. As the relative humidity increases at a certain temperature, the specific volume of the air also increases. And the last is find the diagonal enthalpy scales surrounding the chart. Around the extreme of the chart and just outside of the saturation curve, locate the diagonal scales which represent enthalpy in BTU per pound of dry air. Step 2. Reading interior marking. First, find the vertical dew point line just to the right of the y-axis. Find the line with dew point. So for the step 3, drawing conclusion from given parameters. First, identify 2 known measurements that are on the chart. Pick any 2 known measurements available and plot them on the chart where the lines intersect. Second, use a ruler to locate other measurements at the point of intersection. Once you have marked the point where your known measurement intersect, use a ruler to follow the lines extending from the point of intersection to the various scales on the chart. If you are calculating a change in any of the measurement over time, plot the points on the chart and gather all of the measurement possible for each point from the chart. And last, visualize 2 measurements by comparing them on the chart. From there, compare the difference in the measurements and make note of how the change affected the air.
So I'm going to continue this presentation by present about the problem based on humidity chart. There are a few problems that relate with this humidity chart, which is the first one is the dry bulb temperature. Next is wet bulb temperature, relative humidity, absolute humidity, dew point temperature, specific volume, and the last one is enthalpy. So for the next slide is the humidity chart, graphical display of air water vapor mixture properties. So there are three problem properties that relate to this humidity chart, which is specific enthalpy, humid volume, and the last one is the relative humidity. So this is our question based on humidity chart. So our question is 150 meter cube humid air per minute enters the heater at 15 degrees Celsius and 15% of relative humidity. So use a humidity chart to calculate the heat required to heat the air to 45 degrees Celsius. So uh, based on our questions, our temperature in is 50 degrees Celsius and our temperature out is 45 degrees Celsius, and also our relative humidity is 50%. So, so we can figure out the value of enthalpy, delta enthalpy in, delta enthalpy out, enthalpy in, and enthalpy out. So based on our psychrometric chart that we draw, based on the, based on based on the value that we get from the questions, our enthalpy in delta enthalpy in is 28.5, our delta enthalpy out is 60, our enthalpy in is 0 0.1, and the last one is enthalpy out, which is 0.9. So first we have to find the specific enthalpy. So the formula is specific enthalpy equals to enthalpy out, total enthalpy out minus total enthalpy in. So the first one we have to find the total of enthalpy in. So our delta enthalpy in is equal to 28.5. Our enthalpy in is equal to 0.1. So we have to use the formula, which is enthalpy total enthalpy in is equal to delta enthalpy in minus enthalpy in. So our enthalpy in, our total of enthalpy in will be equal to 28.4. So next one is we have to find the total of enthalpy out. So the formula is the same. So our delta enthalpy out is 60. Our enthalpy out is 0.1. So we just minus 10 and will be equal to 50, 59.1. So based on our first formula, which is delta enthalpy equal to enthalpy total enthalpy out minus total enthalpy in. So 59.1 minus 28.4 will be equal to 30.7. So 30.7 kilojoule per kgDA is our value of delta enthalpy. So next we have to find the mass flow rate. So our volume flow rate is 150. Our V hat is equal to 0.83 based on the psychrometric chart. So the formula of mass flow rate is volume flow rate is divided with V hat. So 150 divided with 0.83 will be equal to 180.72. So this is our value for the mass flow rate. So for the last one is the calculation for energy balance. So this is the calculation for energy balance, which is delta mass flow rate will be timed with delta enthalpy. So 180.72 will be timed with 30.7 will be equal to 5,548.104. And that's all from us. Thank you.